Example 2, finding minimum distance. So very similar to number 1, except instead of trying to find a relative max, we're going to find a relative min. Okay? The reason why is which points on the graph of y equals 4 minus x squared are closest to the point 0, 2. So closest would indicate a minimum. Okay, so here is the graph, which is a parabola. We want to figure out which point on this parabola is closest to 0, 2. Okay, so to figure out which one is closest, we need the distance formula. Right? We want the distance here. And the distance formula is x1 minus x2, that quantity squared, plus y1 plus minus y2, that quantity squared. Okay, and then for our particular problem, I'll call this x1, y1, and I'll call this x2, y2. You could go the other way, flip these around if you wanted to. So x1 is 0 minus x2, which is x squared, plus y1 is 2 minus y2, which is y squared. Then let's see here. This is going to be x squared plus 2 minus y squared. And I can write this in terms of x. So I can make this d of x, make it a function. X squared plus 2 minus y is 4 minus x squared. All that is squared. And let's see here. This is going to be 2 minus 4 plus x squared, squared. This would be x squared minus 2 squared. And then I can multiply this out, where this would be x to the 4th minus 2x squared minus 2x squared plus 4. So this is going to be x squared minus 4x squared. Oh, this should be x to the 4th. Let's see, plus x to the 4th minus 4x squared plus 4. So this would be x to the 4th minus 3x squared plus 4. So now we have this function here. We have d of x equals the square root of 4, or x to the 4th minus 3x squared plus 4. So we came up with that. Let's erase this so we have some room. Now we're trying to minimize this. So to find the relative min, it's going to happen at critical numbers. To find the critical numbers, we need to do the first derivative. So this can be thought of like this, and this would be the power rule, which would end up being machine rules. So it's going to be 1/2 x to the 4th minus 3x squared plus 4 to the negative 1/2 power, and then you have to take the derivative of what's inside here. So this would be 4x to the 3rd minus 6x. And then you can think of this as 4x cubed minus 6x all over 2 times x to the 4th minus 3x squared plus 4 to the 1/2 power. And now we need to figure out x values where the derivative equals 0 or where the derivative does not exist. So if we set the numerator equal to 0, that will tell us the x values where this derivative is equal to 0. So here I could factor out an x, really factor out 2x, leaving me with 2x squared minus 3 equals 0. So x is going to equal 0, or 2x squared minus 3 equals 0. So 2x squared equals 3. Divide by 2. X squared equals 3/2. Square root both sides. X equals plus or minus the square root of 3/2. So here are some critical numbers. Also, to satisfy this, we need to take the denominator and see if we can set this equal to 0, which would tell us where the derivative does not exist. And if you look here, if we try to factor this, it would be x squared, we need to find factors of 4 that add up to negative 3. Nothing's going to work there. So that doesn't work. So we have our critical numbers. Now we need to figure out which of these numbers are minimums or maximums. So one approach would be to use the second derivative test and check out concavity. But to take the second derivative of that, it's going to be a pain. Instead, let's look at the intervals from negative radical 3/2, 0, and rad 3/2. Alright, so we got from negative infinity to negative rad 3/2, negative 3/2 to 0, 0 to positive rad 3/2, and rad 3/2 to infinity. So we're going to test each of these intervals, see if it's increasing or decreasing. So here, let's test negative 2. If I I plug -2 into this, let's see. Let's simplify this a little bit. We can divide all these by 2. This would be 2x cubed minus 3x all over x to the 4th minus 3x squared plus 4 to the 1/2. Here you can factor out an x. You have 2x squared minus 3 all over x to the 4th minus 3x squared plus 4 1/2. Okay, so if you plug in -2, this is going to be -2 here. This is going to be 8 minus 3. So the numerator here would be negative. The denominator, let's see, this is going to be 16 minus 3 times 4 plus 4. That's going to be positive. So this is going to be less than 0 here. Here, so let's see, this is decreasing. Here, this interval here, I can test b prime of -1. So -1 in the numerator. This would be -1. This would be 2 minus 3. So that's a negative times a negative. That's going to be a positive. Denominator, this would be 1 minus 3 plus 4. That's going to be positive. So this is greater than 0. So this interval is going to be increasing. This interval here, I want to test b prime of 1. This would be 1. 2 minus 3, that's going to be negative. This would be 1 minus 3 and 4. 1 minus 3 and 4, that's going to be positive. So this is going to be less than 0. Last one, you want to test 2. So this would be 2. 8 minus 3, that's going to be positive. And the denominator, let's see, this would be 16 minus 12 plus 4, that's going to be positive. So that's going to be greater than 0. Which means here and here, you have a relative min. That's relative min. Then to figure out the corresponding y, you need to plug that in here. So let's do y equals 4 minus. This is going to be 4 minus 3 halves. This is 8 halves. So this would be 5 halves. So the points are going to be at radical negative root of 3 over 2, 5 halves, and radical 3 over 2, 5 halves.